to our educational vlog. In this video, you will be learning about the boiling point elevation and the freezing point depression. If you're one of these students who wonder about this topic too, you only need to watch this educational vlog. Without further ado, let's go! Boiling point elevation is the raising of the solvent boiling point due to the addition of a solute, and the solution boils when a vapor is equal to atmospheric pressure. And for you to understand what is really mean of this, my co-vlogger will discuss this.
Alright, so one of the colligative properties that you're going to see in class is we're going to talk about boiling point elevation. And that is the temperature difference between the boiling point of a solution and that of a pure solvent. And as you can probably guess from the title, it's actually going to increase from the solvent to the solution. The solution is going to have a higher boiling point than the solvent. And why is that? Let's define boiling point first. Boiling point is when vapor pressure of whatever substance you're dealing with is going to equal the atmospheric pressure of the pressure around it. Okay, great. So let's say we have a pure solvent. Let's say we have a beaker of water. We know that at the surface of water, those particles are going to escape into vapor, back and forth, and they're going to have some sort of pressure up here. And as we heat the substance, that pressure is going to rise due to kinetic energy increasing, and it's going to eventually reach the atmospheric pressure and then boil. Okay? So let's go over to a solution. Let's say we put something in it, let's salt, sugar, whatever your solute may be. And to make that solute actually dissolve, those water molecules are going to surround it. So those water molecules are actually really attracted to the solute that's in the solution. So what's going to happen is they'd rather be around these dots or these solute particles than escaping into vapor. So they're already going to start off at a lower vapor pressure. So they actually have to go increase kinetic energy a lot more to reach that vapor pressure to equal the atmospheric pressure because they're already starting at a lower place. So that temperature is going to have to be a lot higher, or depending on what the solvent is, to reach that atmospheric pressure and then boil. Okay, so let's talk about the different solvents and how the solutes are actually affected by them. So let's talk about water. We know water boils at 100 degrees Celsius, and it's found for every molal of solute that you put in there, it's going to increase the temperature, the boiling point temperature, by 0.512 degrees Celsius. Benzene boils at 80.1 degrees Celsius, and every molal, or every mole per kilogram of benzene you put in is going to raise the temperature 2.53 degrees Celsius, or boiling point temperature that much, and so on and so forth. So basically, for this in a nutshell, we have a formula here that's the boiling point elevation formula, and this is a change in temperature of the boiling point. That delta T is going to be the change in temperature times that constant that you see for every molal, that's the amount of degrees Celsius is going to increase, times the molal, the molality, which is the moles of solute divided by the kilograms of the solvent, and we're going to multiply it by the Van Hoff factor, or how much it's actually dividing up. Remember, electrolytes actually dissolve and separate themselves in water. So if you have 1 molal of, let's say, NaCl, you're actually going to have 2 molals of particles. So that is what we call the Van Hoff factor. So let's actually look at that in real life.
The equation for boiling point elevation, delta T is equal to Kb times m times I, whereas delta T is the change and the boiling point, and Kb is the boiling point elevation constant, and the small m is the molality or molar concentration, and I is the Van Hoff factor of solution. I have this example to find the boiling point elevation. 200 grams of sodium hydroxide was dissolved in 200 grams of water. Calculate the boiling of the solution. The Kb for water is 0.51. For us to get the boiling point elevation of example number 1, we need to follow the step 1, calculate the molality. The molality is, the formula of molality is small m equal of mole of solute over kilogram of solvent. So we have a 220 grams of sodium hydroxide as a solvent, so we need to convert it into mole. 200 grams of sodium hydroxide times 1 mole over 40 grams of sodium hydroxide. If you're wondering kung asa gikan ta sa 40 grams, so gikan na siya sa molar mass sa NaOH na 23 plus 16 plus 1. So after that, i-divide na to ang 200 grams sodium hydroxide sa 40 grams sodium hydroxide. That's why we get 0.5 mole. The next is the solvent. So we have a solvent 200 grams of water. We need to also to convert it into kilogram. We all know that 1 kilogram is equivalent of 1000 grams. So 200 grams of water divided by 1000 grams, we get the answer of 0.2 grams. The next step will be determine the Van 't Hoff factor of solution. 1 mole of sodium hydroxide produces 1 mole of Na plus and 1 mole of OH negative. So the Van 't Hoff factor of solution will be 2. The last step is find the delta T. Delta T is equal to Kb times M times I. So we already have the 3. The 0.51 times 2.5 times 2. So we get the answer 2.55. The next is delta TB equals 100 plus 2.55. So the 100 is the normal boiling point plus 2.55 na delta T. That's why we get the 102.55 degrees Celsius.
So guys, for the second question. Are you alright, guys? Are you having a hard time? I hope you're not depressed. Me? Just having a hard time reasoning. Just kidding. Let's go back to the original question. What is boiling point depression? Freezing point depression is the lowering of a solvent's freezing point due to the addition of a solute. In fact, as the boiling point increases, freezing point decreases. Anyway, Kay and Yessa will discuss the computation of a freezing point depression.